Now the next step is to do this the other way. So we are going to deploy our greeter. We are going to send a message from L2, which is scroll, to L1, which is sepulchre in our case. So since we are sending the message from scroll, our operator will be deployed on scroll. So let's do that now. Close all this and start all over. Right, so first we'll deploy our target, which is the greeter, on sepulchre. It's already been compiled, so once to deploy. So we are currently already on the sepulchre blockchain. So what do? We deploy on sepulchre. Deploying targets on sepulchre. Now we confirm the deployment. Go back to our browser. We go to our sepulchre Etherscan, and then we come here, copy. This was the last greeter operator we deployed, but this is the greeter we just deployed on sepulchre. So we copy it, and this is our way of actually saving the address. Just paste it here, and we can verify the contracts, verify and publish using the latest compiler. It's an open source MIT. We continue, and then we come here to copy this, we paste it here, we verify and publish. Similar to what we did. So the reason why we are verifying is so we can access the functions on the Explorer publicly. Read contracts. You will see that it still has this hello world string on it. Now we want to deploy our greeter operator. This one. We want to deploy it on scroll sepulchre. Scroll sepulchre. So come here, change this, and sure enough, our network changed. So we are going to deploy this on scroll sepulchre. So this is okay. So we had the interface selected. That's why I was getting that. So we select the actual operator. Yeah. So initially we had this interface selected, which is the one that we imported. So because I highlighted this particular contract, is why this and the actual greeter operator came into became part of the options we could select. But now we have to select this one because this is what we actually want. I will deploy it on scroll sepulchre. Now confirm. We'll go back to our browser, and sure enough, our latest deployment is down here. And then go to the block explorer. Scroll scan, because we are sending a message from L2 to L1. So come over here and we input the address we just copied, in your latest greeter operator address. And we verify and publish. select our compiler as usual, select our compiler version, select our license. This MIT license is what we have up here for those I don't know. So that's why we're using the MIT license. I don't know if you can use any and how that would affect the outcome. Let's just save. So the contracts, as per previously, we are going to use the flattened contract, right? Remember how we flattened this contract the other time? I come in over here and right clicking on the contract wanted to flatten. If you're using a Mac, I guess depending on your gesture, you double click. So yeah, and then you select flatten, and that's how we got this. Now we copy everything, Control A, Command A, Command C for the Mac users. When the contents in the box in the window is highlighted, we paste, and then do this. We have to verify that we are not robots. Verify and publish. So yeah, we visit our contracts main page and we see that it has been verified. So what we want to do now is send a message. Right now, first we connect to Web3, the Block Explorer. Now, for sending a message from L2 to L1, we are not going to be using any gas. So our payable amount is 0. Okay. Now the scroll messenger address will be our scroll messenger. Will be the address of our scroll messenger on Sepolia. So if you look at the official scroll docs which I've been using, it said here that if you deploy it on scroll Sepolia, use this. So that's going to be it. Our target address will be our contracts on L1 that we're sending the message to. That's our target. Our value will be 0. Our greeting string will be this message was sent cross chain. I think I would just send cross chain. This message was cross chain, so let's just add this to it. T002 T, and our gas limit will be 0. Right, since we are not sending any value, right, we don't have a gas limit. Let's see if that works. So that works. I think it might just might not work. Okay, so let's confirm that. This is our latest transaction. Just 1 second ago. So yes, our transaction went through. But there is one more step for sending a message from L2 to L1. You need to, let me just do a quick share confirmation that our transaction went through. Okay. This is the contract creation transaction, and 6 minutes. This should be the interaction with the function, execute function cross-chain. That's it. So now, one more step, we have to relay the message, right? So we are sending this message from L2 to L1. Now I want to relay the message from the L1 scroll messenger. That's where we're going to relay the message from. So we'll go to the Etherscan Sepolia, and we are going to look for, this is the scroll messenger on L1, right? Our L1 that we are using now is Sepolia, but if you are working with a live project, you're probably using an L1. You'll be using Ethereum. So this is where we are going to write as proxy, right? And this is the function we want to interact with, relay message with proof. Now we are going to get the claim info that we need from the API, Sepolia API. This is currently the easiest way as per the docs to get it. So get our API. So we can just query directly from our browser. I used this to query it one time. I used Postman, and that gives you a prettier rendition. But setting up Postman on this browser right now, let me just do that. Let's see if we can do it without Postman. So greeter operator address on L2. This is L2. Our L2, remember, is Sepolia scroll. So we change the address here. We impute. Yeah, but what we notice is that there is no results right now. So interestingly, it's looking like Firefox, which I'm currently using, prettifies, quote and unquote, the results. Chrome wouldn't do that. So I used Postman on Chrome. Postman on Chrome gave me a prettier result, Postman, but using the Chrome browser gave me a very non-pretty result. So anyway, we are going to have to wait about 20 minutes for our message to be finalized on L1. Then we can get our claim info. So this is a ZK roll up. So finality even on mainnet will take about the same time, but for an optimistic roll up, finality would have to be delayed for longer in order to give people the opportunity to challenge it. I think it's called a fault window, to challenge the results, right? So we wait to get our results. Okay, so after over 30 minutes, I have gotten my relay message. My transaction has been finalized. Right, okay, which reminds me, Scroll has an explorer. Let me check that explorer out. They have an explorer for Scroll Rollup Explorer. All little transactions are bundled into batches. You have to wait for the batch that includes a transaction to finalize before calling, which was what we did. The transaction batch index is returned in on the claimable endpoint. It's the claimable endpoint we called here. So it's a claimable endpoint we called here. But something this scroll but if you noticed, before I was able to get the results here, there was no way for me to see the batch index, and therefore there would have been no way for me to track, right? If I don't know my batch index, I wouldn't have known which one exactly I was supposed to track. So that's something the people that wrote that documentation might want to look into. Anyway, this is their Rollup Explorer. So when you send a message and I guess any transaction from an L2, from their L2 to L1, you can track it here. I wonder if this Rollup Explorer is for mainnet, and there's a different one for testnet. So anyway, thanks to Firefox, just imputing our URL here gave us the specified version of our API call, so we can copy our values in a nice way. So we want to call the relay message with proof function on the messenger, on the L1 messenger, scroll messenger contract. So the from address, this is the greeter operator address, right? 0x8a ends with 97a. From 0x8a ends with 97a is what our API gave us. So we come and see on the to address. I suppose this will be the greeter address, OX1C. Let's see, OX1C ends with BA7. That's it. Let's see. The value is 0 as seen here. The nonce, this is the nonce. So message, this is the message. I'm gonna copy the message. Okay, make this faster. Okay, I think I'll copy it. I will paste it here. Message. Up next is the proof batch index and make a proof. So proof. First we copy the batch index. Next we copy the proof. Then we make sure our wallet is connected to the block explorer. So that's connected. What's our network? Yes. And then we write the function. So something's wrong here. So what's wrong? So nothing else. Figure out what is wrong. So